A phone company charges 20 cents for daytime minutes and 5 cents for nighttime minutes. How many day and night minutes would you have to use to be charged more than $10 in 24 hours? So this situation represents an inequality in two variables. So let's let D equal the number of day minutes, and let's let N equal the number of night minutes. Now there's one more issue to deal with. The charge per minute here is in cents, but then we want to answer the question based upon being charged more than $10. So we have to either convert the cents to dollars or dollars to cents. And to avoid decimals, let's convert $10 to cents. Since $1 is equal to 100 cents, then $10 would be equal to 10 times 100, or 1,000 cents. Now see if we can write an inequality to represent this situation. Every daytime minute costs 20 cents, so the amount of money spent on daytime minutes would be 20 cents times D, plus the amount of money spent on nighttime minutes would be 5 cents times the number of night minutes, or 5 times N. We want to know when this would be more than $10 in 24 hours or greater than 1,000 cents. So now we'll go ahead and graph this inequality, where the graph would show all the possible solutions to this given inequality. So we'll let the horizontal axis equal the D-axis, which represents the number of day minutes, and we'll let the vertical axis be the N-axis, which represents the number of night minutes. So we need to graph this inequality. So the first step is to graph the borderline. So we'll go ahead and graph the line 20D plus 5N equals 1,000. And because the original inequality is greater than, the line will not be part of the solution, and to show this, we'll make a dashed line. And since this line is in standard form, let's go ahead and find the x and y intercepts to graph the line, or in this case, the D and N intercept. So to find the D intercept, we'll set N equal to 0, and then to find the N intercept, we'll set D equal to 0. So if we set N equal to 0, 5N would be 0, and we'd have 20D equals 1,000. Divide both sides by 20, and we have D equals 50. So the D intercept is equal to 50, and now we'll set D equal to 0, and if D is equal to 0, 20D would be 0, and we'd have 5N equals 1,000. Divide both sides by 5, and we'd have N equals 200. So now we can plot these 2 points and sketch our line. But before we do this, let's go ahead and scale our axes. If we call this 200, then this would be 100. If we let this equal 50, then this would be 25. So now we'll plot the point 50, 0, which is the D intercept, this point here. And then we'll plot the point 0, 200, which is the N intercept, which is this point here. And now we'll sketch a line through those 2 points. And again, we said it was going to be dashed because of the original inequality symbol. So it's going to look something like this. And now we need to figure out whether we're going to shade below the line or above the line. And notice how we're only considering the first quadrant because we know that the number of minutes can never be negative. Now that we have the graph of our borderline, we have to figure out whether we should shade above or below the line. So if we select this point here as our test point with coordinates 0, 0, it's going to be very easy to see that when D is 0 and N is 0, 0 is not greater than 1,000, and therefore this point does not satisfy the inequality, so we have to shade the other side of the line, or this side here. So any point in the shaded region represents a combination of the number of day and night minutes that would have a charge of more than $10. So we could probably figure out logically that if this was a line where the charge would be exactly $10 or 1,000 cents, then any point above this line would represent a combination of day and night minutes that would be more than $10, and therefore would be in the region that would represent the solution to this linear inequality. I hope this example helps.